is Timothy Joseph Acob. Again, good evening. I'm gonna report this topic. Plate number 2. We have here the problem, ma'am. So, ilayo ko lang yung camera. For the wall footing shown in the figure, which of the following most nearly gives the effective soil pressure if the allowable soil pressure is 200 kPa? The effective soil pressure is the remaining soil pressure available to support the loads after the effects of the soil and concrete weights are subtracted. So we have him FC prime 28 MPa, Fy is 280 MPa, and use 2001 and the CP specs. So unit weight of concrete is 24 kilonewton per cubic meter. Unit weight of soil is 16 kilonewton per cubic meter. Allowable soil pressure is 200 kPa. We have here the dead load, which is 200 kilonewton per meter, and the live load is 180 kilonewton per meter. So the figure here, ito siya. And question A, question A yun, question B tayo. Which of the following most nearly gives the minimum width of footing rounded to the nearest 0.10 meters such that the effective soil pressure will not be exceeded? Which of the following most nearly gives the ultimate shear due to factored loads acting on the critical section? So here's the solution. Effective soil pressure is equals to QE 200 na this one, that load minus 24 times 0.46 minus 16. Yung 16 natin is, ayun siya, yung unit weight of soil, and times 0.74. QE, makukuha natin na 177.12 kPa. So, letter B, width of footing. So, consider 1 meter strip of wall. Moment tayo. 90 times 1.5. 90 times 1.5. Ito siya. Hanggang dito. So, we have 135 kilonewton meter. To get the Q max, we have here the formula P over A plus MC over I. So, pwede din ito. P over A plus 6M all over BD square. So, punta tayo dito. We have here. Ayan. Pwede rin siyang itong formula na to. So, we have here 177. Yung nakuha nating QE. Excuse me. QE 177.12 is equals to 380. Pinag-plus natin yung dalawang loads. All over L plus 6 times 135 all over L is squared. So, ito siya, 177 L is squared is equals to 380 L plus 810. So, yan. L squared minus 2.145 L minus 4.573 is equals to 0. Gawin natin siyang ganyan. So, ang makukuha natin length is 3.47, say 3.5 meters. Okay. So, total shear at critical section, we have here PU is equals to 1.4 dead load plus 1.7 live load. Ay, baliktad ata. Ayan, tama. So, PU we get 186 kilonewton. So, ito yung H. Okay. 60, ito siya, yung 30 plus 30 kilonewton per meter times 1.4 plus 30, yung isa lang, and then 1 times 1.7 is equals to 35 kilonewton. So, to get the MU, we have here 135 yung moment times 1.5 na yung height. Ayan. MU is equals to 202.50 kilonewton meter. So, Q max, P all over L times 1 plus 6 MU all over 1 times L squared. So, Q max is 586 all over 3.5 plus 6 times 202.50 all over 3.5 squared. Kuha natin yung Q max na 266.62 kPa. So, to get the Q min naman tayo, PU all over L, negative, minus 6 MU all over 1 times L squared. So, we have here PU, yung PU natin dito kanina, na 585 all over 3.5 minus 6 times 202.50 yung MU natin, all over 3.5 squared. So, Q min is equal to 68.24 kPa. Ratio and proportion, we have here X all over 2.386 is equals to 193.38 all over 2.5. So, X is 135.24. Getting the V or the, what do you call that? Yung ultimate shear due to factored loads, we have here 203.48 plus 266.62 all over 2 times 1.114 times 1. We have the shear 261.87 kilonewton. This is problem 2 from plate 2. So we have a 400 square tied intercolumn supports a dead load of 890 kilonewton and live load of 710 kilonewton. The column is reinforced with 8.25 diameter bars as a square footing is designed to support this load with its base at 1.5 meter below the ground surface. Allowable soil pressure is 240 kPa. Assumed soil weighs 15.74 kilonewton per cubic meter and concrete to be 23.5 kilonewton per cubic meter. FC prime is equals to 20.7 MPa and Fy is equal to 415 MPa. So, determine the dimension of the square footing. B. Determine the reinforcement of the square footing. And letter C. Determine the required development length of the square footing. Reinforcement location factor is equals to 1.3. Coating factor, beta is 1. Lightweight aggregate concrete factor is 1. So we have here solution. So A, dimension of square footing, assume a total depth of 600 millimeters with an effective depth of 600 minus 75. We have here 525 millimeter. So ito siya ma'am, may figure. Effective soil pressure is equals to 240 yung masan na siya? Ayan, 200 kPa minus 0.60 meters times yung unit weight na yung concrete weight na 23.5 minus 15.74 na soil weight and times 0.9. Ito siya. We have the effective soil pressure here na 211.73 kPa. Area required is equals to dead load plus live load all over effective soil pressure. We have here the L squared is equals to 890 plus 710 all over 211.73. We have the length here 2.74 meters. So moving here, you have the ultimate upward soil pressure, which will be 1.2 times dead load plus 1.6 times live load all over area. So QU is equals to 1.2 times 890 plus 1.6 times 710 all over 2.74 squared. So we have here QU is equals to 293.57 kPa. Beam shear. So to find the beam shear, we have 293.57 na ito na yung QU times 0.645 times 2.74. We have here yung beam shear, we have the VU 518.93 kilonewton. Pwede din siya ito 1 over 6 theta F square root of FC prime base times AB D. So we have here the VU na gawin nating Newton 518,830 is equals to 0.75 all over 6 times square root of 20.7 na FC prime times yung 2,740 na base times D, which makukuha natin yung D na 332.95 greater siya sa 525. So okay siya. Punching shear, we have 400. Ito siya, nasa na, wait. Ito, 400 plus D. Ayun, hindi natin. So 400 plus 525, we get 925 mm. VU is equals to 2.74 squared minus 0.925 squared times yung QU na 293.57. VU we have 1,952.82 kilonewton. So ito din, but kung na yan siya. Theta F prime square root of F prime C BD all over T. So makuha natin yung BO na 4 times 925. We have here the BO 3,700 mm. So to get the D, we have here the VU here, ito yung video na to. 1,950,820 is equals to 0.75 multiplied by square root of 20.7 times 3,700 times d all over t. So we have the d here na 464 millimeter, which is less than 525 mm is okay. So use 2.74 by 2.74 by 0.6 square footing. So next is B, reinforcement of the square footing. Moment is 293.57 yung QU multiplied by 2.74 times 1.17 MU. We have 550.56 kilonewton meter. So we have here the P mean 1.4 all over Fy. So we have 1.4 all over 415 na Fy natin. We get P mean 0.00333735. Use P mean 0.00333735. So as required, AS is equals to PBD. AS is equals to 0.003275 times 2740 times 525. AS should be 4053 mm squared. Next, we have so here, using 25 mm diameter bar, we have here the pi over 4 multiplied by 25 mm squared, and n is equals to 4053. We have n is equals to 8.2689. So use 9.25 mm, 9.25 mm diameter bars with both ways. As for this, we have here pi over 4 is equals to 25 squared times 9. So, ito siya. And next is letter C. We have to find the required development length. So, LD all over D2 is equals to 9 Fy times alpha plus beta times gamma times lambda. So, all over 10 multiplied by square root of FC prime times C plus KDR over DB. So, we're getting C is equals to 75 mm steel covering, KTR 0, no stirrups. So we have here C plus KTR over DB is equals to 75 plus 0 all over 25 is equals to 3. Greater than 2.5, so use C plus KTR over DB is equals to 2.5. Now we have here LD all over DB is equals to 9 times 415 na Fy times 1.3 times 1 times 1 all over 10 times square root of 20.7 times 2.5. So we get the LD here 42.69. Now LD over DB times AS required over AS furnished. So we have here 42.69 times 4053 all over 4,418. We get 39.6. So LD over DB is equals to 39.16. We get LD 39.16 times 25. We get 979 mm required development length. So development length furnished is equals to 2740 all over 2 is equals to 200 minus 75. LD is equals to 1095 mm is greater than 979 mm. It is okay. So therefore, the required development length is 979 mm. Moving on here on problem number 3, we have a 400 mm by 400 mm column carries a dead load of 890 kilonewton and a live load of 710 kilonewton. The column loads will be transferred to the 2.7 meter footing having a total thickness of 500 mm. FC prime is equals to 27.6 MPa for both column and footing, and Fy is equals to 415 MPa. So A, compute the allowable bearing force in concrete at the column base and indicate whether it is safe to carry the actual load. B, compute the allowable bearing force in footing concrete and indicate whether it is safe to carry the actual load. And lastly, C, compute the size of the dowels and its development length. So the solution is here. Allowable bearing force in concrete at the column base is F is equals to theta times 0.85 FC prime area 1. So F is equals to 0.65 times 0.85 multiplied by 27.6 FC prime times 400 times 400 area is equals to 200 is equals to 2439840 Newton, which is 2439.84 kilonewton. Bearing force at base of column is equals to PU is equals to 1.2 dead load plus 1.6 live load. PU we have 1.2 times 890 plus 1.6 times 710. So we get PU is equals to 2,204 kilonewton, less than 2,439.84 kilonewton. So therefore it is safe. Now we have here the allowable bearing force in concrete footing. Theta is equals to F is equals to theta times 0.85 FC prime area times square root of A area 2 all over area 1. So we have yung area na ito. So we have square root of area 2 all over area 1 is equals to 2.7 times 2.7 all over 0.4 times 0.4. We get 6.75 greater than 2.0. So use this formula. 2. F is equals to theta is equals to 0.85 FC prime area 1 times 2. So we have here the 0.65 times 0.85 multiplied by 27.6 na FC prime times 400 na area multiplied by 2 is equal to 4879680 Newton. So allowable bearing force is equals to 4879.68 kilonewton greater than PU. Nakuha natin kanina which is 2204 kilonewton. So therefore it is safe. Now, moving on to letter C, development length of dowels. Minimum AS for dowel is equals to 0.005 times area. So we have here 800 millimeter squared. So using 4 dowels, therefore pi over 8 is equals to pi over 8 times d squared is equals to 800. Therefore d is equals to 15.957, say 16 millimeter diameter. Development length, we have here LD is equals to 0.25 dB Fy all over square root of Fc prime, but not less than 0.04 dB Fy. So therefore minimum LD is equals to 200 millimeter. Now we have LD is equal to 0.25 times 16 here, yung D, multiplied by 415 na ito, Fy, all over square root of 27.6 na Fc prime. We have LD is equals to 316 mm. LD is equal to 0.04 dB times Fy is equals to 0.04, 16 dB, and then 415 na Fy, we get 266 millimeter. Use LD is equals to 316 millimeter. Number 4, a triaxial test is performed on normally consolidated clay. The sample is further consolidated by the test all around confining pressure prior to the application of the axial load. The axial force is then applied very slowly to the equipment. Pore pressure lines remains open so that the drainage of soil, pore water can occur during the test. The described condition outline the procedure for a consolidated drain type test. The samples fails when the lateral pressure in the cell is 2.1 kPa and the maximum principal area failure stress is 61 kPa. So we have here, determine the angle of internal friction for the effective stress strength failure envelope. B, determine the angle that the failure plane makes with the principal plane. And letter C, determine the shear stress at the point of the failure plane. So solution, we have here angle of internal friction, we have 2R is equals to 61 minus 21, R is equals to 20. Now we have sine phi is equals to R all over 21 plus R. We have sine phi is equals to 20 all over 21 plus 20. We get the phi, angle of internal friction, 29.2. Next, move on. Letter B, angle that the failure plane makes with the principal plane. We have here theta is equal to 45 plus phi all over 2. We get theta is equal to 45 plus 29.2 degrees all over 2. We get theta 59.60. And lastly, we have here shear stress at the point of failure plane. Shear stress, shear is equal to R cosine theta is equals to shear 20 times cosine 29.2 degrees. Get the shear stress is equals to 17.46 MPa. For problem number 5, we have the result of two drain triaxial tests on a saturated clay are recorded as follows. Specimen A, chamber confining pressure is equals to 104 kPa, deviator stress at failure is equals to 210 kPa. Specimen B, we have chamber confining pressure 170 kPa and deviator stress at failure 324 kPa. So A, compute the angle of friction. B, compute the cohesion of soil. And letter C, if the clay specimen above is tested in a triaxial apparatus with a chamber confining pressure of 248, compute the major principal stress at failure. So solution, we have here angle of friction. Sine phi is equals to R all over x plus 209. So ito yung x plus 209 from center to here. Origin, parang ganun. So we have 105 na radius all over x plus 209. We have sine phi is equals to 162 all over yan x plus 332 ratio and proportion. We have 105 all over x plus 209 is equals to 162 all over x plus 332. We have 105 times x plus 34860 is equals to 162x plus 33858. So 57x is equals to 1002. We have x here. Nakuha natin x dito na 17.58. So sine phi is equals to 162 all over x plus 332. Yan siya. We get the phi na 27.61 degrees. Next is dito. Same lang sila na 25. Makukuha din natin siya na 27.61. So letter B, cohesion of soil. Tangent phi is equals to C over X. So tan 27.61 ito is equals to C na all over 17.58. Makukuha natin siya na yung C na 9.19 kPa. Yun yung cohesion ng soil. Next is letter B major principal stress at failure when stress 3 is equals to sigma 3 is equals to 248 kPa. So we have sine 27.61 phi is equals to R all over R plus 265.58. I think 260.58 pinag plus yun 209 plus 17.58. Ayan. So we get here 0.463 R plus 123.58 is equals to. So getting the X is 229.20. We have here the stress 1 is equals to 248 plus 2 times 229.20. We get the major principal stress at failure na 706.40 kPa. Number 6, we have a specimen of saturated sand was consolidated under on all around confining pressure of 414 kPa. The actual stress was then increased and drainage of the pore water was prevented. The soil specimen failed with the deviator stress reached 346 kPa. The pore water pressure at the failure was measured from a pore water supply line connected at the base of the soil. The specimen was found to be 286 kPa. So A, compute the consolidated undrained angle of shearing resistance. B, compute the drained friction angle. And C, what would be the deviator stress at the failure if a drain test was conducted with the same chamber all around pressure of 414 kPa. So the solution is here. We have a consolidated undrained angle of shearing resistance na 2R. Ito siya, yung dalawang R. Is equals to 364. Yung R natin is 173. So obviously, sine phi is equals to 173 all over 414 plus 173. We get here what na phi is equal to 17.44 degrees. So B, drain friction angle, we have here same process 173 all over 128 plus 173. So we get the phi prime na 35.08 degrees. And lastly, yung deviator stress as failure, hanapin natin siya. So Same formula, we have sine phi is equals to r all over 414 na ito siya. Ayun, yung KPA here, 414 plus r. So, 414 plus r is equals to r all over sine 35.08 degrees. So, makukuha natin yung r na 559.475 kPa. Change in D. So, ano na siya? Ito yun. Change dito. Makukuha natin to through here. 2 times 559.75 kasi yung radius. Yan. The radiator stress at failure is equal to 1,108.95 kPa. Next problem is number 7. The profile of a soil consists of a soil layer 3.6 meters below the ground surface. The weight of the soil is 19.35 kilonewton per cubic meter. The water table is located at 1.8 meters below the ground surface. The angular friction of the soil is 22 degrees and the cohesion of 30 kPa. The saturated unit weight of soil below the water table is 18.40 kilonewton per cubic meter. So A, compute the effective stress at a depth of 3.6 meter below the ground surface. Compute the neutral stress at a depth of 3.6 meter below the ground surface. And letter C, compute the shearing strength of the soil at the depth of 3.6 meter below the ground surface. So here's the solution for A, effective stress. We have here 19.35 times 1.8 plus 18.40 minus yung gamma ng water na 9.81 times 1.8. We get 50.29 kPa. Next, B, neutral stress is equals to 9.81 times 1.8 is equals to 17.666 kPa. So, yan. And letter C, shearing strength of soil. We have here, shear stress is equals to C, cohesion plus sigma, tangent theta, tangent phi. Yan, we have 30. Yung cohesion natin doon. Problem plus 50.29 tangent of 22 degrees, we get the shearing strength of soil na 50.32 kPa. So, yan. Ito siya. Here, 8, we have here, a spread footing, sabi nga, a spread footing supports a 350 by 350 mm column carrying a dead load of 300 kN and a live load of 500 kN. The footing is subjected to an axial moment produced by the effect of dead load, live load, and earthquake. The unfactored moments are tabulated below. So we have moment dx is equals to 50 kilonewton meter, and for dy we have 30 kilonewton meter. Next is moment at Lx is equals to 60 kilonewton meter and Ly 50 kilonewton meter. We have Mex here for earthquake is 36 kilonewton meter and Mey is equals to 29 kilonewton meter. Thickness of footing is 400 millimeters with an effective depth of 360 millimeters. The bottom of the footing is 120 meter below the ground surface. Unit weight of soil is 15.7 kilonewton per cubic meter and concrete is 23.5 kilonewton per cubic meter. So use 2001 NSCP specs. A, which of the following gives the dimension of the spread footing? And B, which of the following gives the punching stress at the critical section? And lastly, which of the following gives the number of 20 mm diameter reinforcing bar in both ways for the footing? So we have here yung figure niya, ganito siya. So solution, the dimension of the spread footing, we have P, dead load na 300 plus 500 live load. We get the force 800 kilonewton. Yung moment at X natin, total, 50 plus 60 plus 36, we get 146 kilonewton meter. And for moment ng Y, we have 300 plus 50 plus 29, get a total of 109 kilonewton meter. So L is equals to B is equals to D. So we have here FA is equals to P over A plus 6mx all over BD square plus 6my all over BB square. So we're getting this formula here. Next, effective stress, we get QE is equals to 300, yun, yung dead load, minus 0.74 times 15.7 yung unit weight ng soil. And here is minus 0.46 times unit weight ng concrete, 23.5. We get QE is equal to 77.57 kPa. Again, we're gonna use this formula here. to try the length, which is 2.3 meter. So we have FA is equals to 800 total force all over 2.3 squared. Itong trinay nating length here, plus 6.146 na mx all over 2.3 again na length cube plus excuse me 6 times 109 na total ng my all over 2.3 cube. So we're getting here the FA na 276.98 is less than 277.57 na QE, which is okay. So use L is equals to 2.3. Just yung magiging dimension niya. Ngayon, for B punching stress, we have here the PU 1.4 plus force ng dead load and 1 plus 1.7 times force ng dead load. We're getting 1.4 times 300 plus 1.7 times 500. We get the punching stress na 1270 kilonewton. So here, moment UX is equal to 3.75 times 1.4 MU X plus 1.7 MLX plus 1.87 MEX. So ito yung sa pagkuha nito na makukuha natin for punching stress 179.49 kN meter. We're getting here again the formula MUX 1.4 plus MD, which is the dead load, plus 1.7 times ML. Get here the 1.4 times 50 plus 1.7 times 60. So MUX is equals to 172 kN meter. Use MX 179.49 kN meter. So ito yung figure niya, makikita natin ganyan siya. So moving on to the next page, we have here yung figure. Ganito siya. So MUY, sa MUY naman tayo, we have 0.75 times 1.4 moment at dy plus 1.7 moment at ly and plus 1.87 makuha natin yung sa moment at earthquake y. So MUY, we have 0.75 times 1.4 times 30 plus 1.7 times 50 plus 1.7 times 29. So MUY is equals to 135.9 kilonewton meter. So again, gagawin natin yung parang ginawa natin sa MUX. We have here 1.4 plus moment at dy plus 1.7 moment dy again. So we have here MUY 1.4 times 30 plus 1.7 multiplied by 50. We're getting MUY is equal to 127 kilonewton meter. Because MUY here mas mataas kasi mas okay siya. So 135.9 kilonewton meter. So for FA, we have to PU all over L squared plus 6 MUX all over L cube minus 6 MUY all over L cube again. So substituting the values again, ginamit na naman natin yung length here na tinay natin kanina na which is okay, 2.3. So FA is equals to 261.57 kilo Pascal. So we have here for FB, we have 1,270 yan all over 2.3 times squared plus 6.179.49 all over 2.3 cube plus 6 times 135.9 all over 2.3 cube. So we're getting again the value 295.61 kilopascal. For FC, we have here same problem, same formula. Kaso iba yung lalabas dito na 218.58. So here FD natin, we have 1,270, ganun din siya. Minus naman dito. So 6 times 179.49 over 2.3 cube minus again 6 times 135.9 over 2.3 cube. FD is also 84.55. So next, average hull pressure at the center, QU, is equals to 261, yun, 0.57, FA, plus FB, plus FC, plus FD all over 4. Apat na to. We are getting QU is equals to 240.08 kPa. BU is equals to PU minus QU times 0.710 squared. So we're getting VU is equals to 1,148.98 kilonewton. So UP is equals to VU all over VBD. Makukuha natin yung UP na or punching stress is also 1,148,980 all over 0.85 times 710 times 360 times 4. So makukuha natin siya for the value of 1.32 MPa. So less than siya sa square root of FC prime all over T, which is 152. Ngayon, safe siya. Next is, so for C, steel requirements, consider only 1 meter strip. So nag-consider tayo ng 1 meter strip. So we have here 395.61 times 0.975 times 1 meter times 0.975 all over 2. We're getting MU as 188 times 10 raised to 6, or kapag na ano siya, convert na siya. So MU, V, F prime C, BD square, W times 1 less 0.59. And formula, we're getting 188 times 10 raised to 6 is equal to 0.90 times 21 times 1,000 for conversion times 360 squared, W times 1 minus 0.59 W. So we're getting the W here, which is 1 minus 0.59 W minus 0.077. So, ito siya. Ganyan siya. Nakuha natin yung value ng W na 0.081. So, E is equals to WFC prime all over FY. So, substituting the values, makukuha natin itong P na 0.0041. So, to get the P min is equals to 1.4 over Fy. So, ito yung value ng P min natin na 0.00338. Use P is equals to 0.001. AS PB is equals to PBD. AS is equal to 0.0041 yung ginamit natin here times 1,000 times 360. Ito yung 1 meter na convert. AS is equal to 1,476 mm squared. Using 20 mm diameter bars, we get pi all over 4 times 20 mm diameters squared times 1,000 all over S is equals to 1476. We're getting the S here is equals to 212.85 mm on center is equals to 210 mm on centers. Yan. Number of bars is equals to 2,300 all over 210 na S plus 1. We're getting the number, we're getting ito yung steel requirements. So here, N is equals to 11.25 C12 bars. Problem number 9, we have here a 450 mm square interior column carries a dead load of 825 kilonewton and a live load of 668 kilonewton. A rectangular footing is required to carry the column loads such that the length of the long side must be equal to twice the width of the short side. Assume base of footing is 1.5 meter below the ground surface. Allowed bearing pressure of soil is 192 kPa. So we have FC prime is equals to 27.6 and Fy na 415 MPa. Weight of soil is 15.74 kilonewton per cubic meter, and that of concrete is 23.5 kilonewton per cubic meter. For A, determine the dimension of the rectangular footing. For B, determine the longitudinal steel requirements. And letter C, determine the steel requirements in short direction. So here we have here the figure. Yan siya. May total depth siya ng 1.5. Solution, we have dimension of the rectangular footing. Assume total depth of 600 millimeters. Effective depth is 600 minus 75 is equals to 525 millimeters. Effective soil pressure, we have Q effective is equals to 192 minus 0.6. Ito, 0.6 na ito. Times 23.50. Yung 23.50 is siya yung unit weight ng concrete. Minus 15.74 yung unit weight ng soil. Times 0.9 na depth niya. So QF is equals to 163.73 kPa. Area required, we have here the LW, we have DL plus LL all over QF. We're getting 2W times W, we have 825 plus 668 all over 168.73. Hindi ko natin nag-effective. So we're getting W is equals to 2.14. And length is 4.28. So area is equals to 2.14 times 4.28 length minus 9.16. So ultimate upward soil pressure, we have QU is equals to 1.2 times dead load plus 1.6 live load all over A. QU is equals to 1.2 times 825 plus 1.6 times live load na 668 all over area na 9.16. So we're getting QU as 224.76 kPa. Considering one-way shear, so we have VU 224.76 times 1.39 times 2.14. So VU is 668.57 kilonewton, and also VU is equals to Phi times square root of FC prime base times D all over 6. So we have here yung V natin na 668.57. Is convert natin siya into newtons, equals to 0.75 na Phi times 27.6 square root for FC prime plus times 2140 times D all over 6. We're getting the D 476 is less than 525, so okay siya. Considering two-way shear, punching shear, V is equal to 224.76 times ito 4.28 times 2.14 minus 0.975 squared. So makukuha natin to VU is equals to 1844.96 kilonewton. Yan yung kinonvert natin siya into newton. So VU again, so we have Phi here, yan siya. So to get BO naman, yung base is equal to 4 times 975, makuha natin yung 3,900 millimeter. And substituting the values here, so to get the D again, is makukuha natin siya for 16 mm square Newton 525 mm again. Okay, so use 2.14 by 4.28 meters by 0.60 meters. So ito yung dimension ng rectangular footing natin. Ganyan siya. And next page again. For letter B, longitudinal steel requirement. So MU is equals to 224.76 times 1.915. Ito siya yung dito, yan siya yun. So times 2.14 yung distance naman dito. Makukuha natin times 1.915 all over 2. Ito siya. So MU is equals to 881.94 kilonewton meter. So MU, we have here Phi FC prime BD squared W times 1 minus 0.59 W. So formula to guys, again, yun nakuha natin value na MU natin na 881.94 times 10 raised to 6 is equals to 0.90 times 27.6 na FC prime plus to 140 na B times 525 squared na D. W times 1 minus 0.59 W again. Ano lang, algebraic manipulation. So makukuha natin yung W as 0.0624995. So W again is equals to P Fy all over FC prime. So yung W natin na ito is equals to P. Para makuha natin yung P times 415 na Fy natin sa given all over FC na given 27.6. So we have here the P is equals to 0.00416. P mean is equals to 1.4 all over Fy is equals to 1.44 over 415. We're getting here the value 0.00337. Use 0.00416 for P. So we have here for formula for such steel requirements AS PBD. We're getting here area ng steel 0.00416 times 2140 times 525. So ito yung value niya 4674 millimeter squared. Using 25 mm bars, diameter bars, we have here the formula na pi over 4 times 25 mm diameter bars squared. And is equals to 4674 yung area natin sa steel. We're getting the number of steel here 9.52, say 10 bars. Use 10 na 25 mm diameter bars. So, yun yung sagot natin sa letter B. For letter C, we have here reinforcement in short direction. So, MU is equals to 224.76 times 4.28 times 0.845. Yun. Divide element natin siya sa 2. To get the MU is equals to 348.44 kilonewton meter. Again, MU is equals to phi FC prime D BD squared W times 1 minus 0.59 W. We're getting yung MU here 343.44 times 10 raised to 6 is equals to phi natin na 0.90 times FC prime na 27.6 times B na 4280 times D na 525 squared W times 1 less 0.59 W. So, manipulating again, equating the equation to 0. Makuha natin yung W natin as 0.0118. So, W is equals to PFY. So, PFY all over FC prime. So, ito siya. Ganito yung figure niya. So, 0.0118 is equals to P times F y na 415 all over FC prime na 27.6. We're getting the P 0.00078. Use P min. Mas malaki yung value ng P min na to, 0.0037. So, area ng steel is equals to PBD again. Substituting the values, nakukuha natin yung area ng steel na 7572 mm squared. Reinforcing in bandwidths all over. Total reinforcement in short direction is ito yung formula 2 all over beta plus 1. So, beta is equals to length over width. Makukuha natin yung 2W all over W. So, siya. Beta is equals to 2. Now, we have here yung reinforcing bandwidths all over total reinforcement in short direction. We're getting 2/3. So, here, AS1 all over 7572 is equals to 2/3. Nakuha natin yung area ng S1 na 5,048 mm squared using 22 mm diameter bars. So, using this formula, pi over 4 times 22 squared n times is equals to 5048. So, number of bars is equals to 13.3. Say 14 bars. Yes. AS1 is equals to pi over 4, 22 squared times 14. Kukuha natin yung AS1 na 5322 mm squared. So, para makuha natin yung total is 2AS2 plus AS1 is equal to A total. So, ayan, substituting again the values, makukuha natin sa AS2 is equal to 1125 mm squared. So, para sa 22 mm diameter bar, we have pi over 4 times 22 squared and is equal to 1125. So, n is equal to 2.9. Say 3 bars. Ayan. For number 10 problem, we have here, the figure shows a spread footing subjected to an actual load and a moment as indicated. Allowable bearing pressure is 240 kilopascal. A 1/3 increase in bearing pressure is allowed for wind and earthquake load, neglecting weights of overburden and concrete. A. Compute the minimum size of the square spread footing with the given loads and moments. So, we have here the given. And for B, compute the minimum size of the square spread footing for combined gravity and wind. Here's the given for B. And for C, compute the minimum size of the square spread footing for combined gravity and seismic load. So, we have here the given again for letter C. So, solution. For A, minimum size of spread footing for gravity leads only, we have P, 1,350 plus 650. Ayan yung load niya. Nasa na siya yung A, 1,350 and 650. So, we have here 2,000 kilonewton. And the moment is, M is 60 plus 20. We have here 80 kilonewton meter. So, next, F is equals to P over A plus or minus 6m all over L cube. So, we have F here na 240. yung pressure niya 240 is equals to yung load natin kanina na 2,000 kilonewton all over L squared plus 6 times 80. Ito, yung M natin. 80 all over L cube. So, trial and error natin, we have L is equals to 3 meters. For lateral and gravity loads, F is equals to 1.33 times 240. Makukuha natin yung pressure niya na 319.20 kPa. So, yung P natin na 1,350 plus 650 plus 1118.5 na seismic and gravity loads control. We have here P na 3,118.50 kilonewton. So, pressure F is equals to P over A plus negative MC all over I. So, we have here the P all over L squared positive negative 6M all over L cube. So, gagamitin natin ito. Yung pressure natin dito na 319.20 is equals to 118.5 na pinatin dito all over L cube plus 6 times 80 all over L cube. So, trial and error. We're getting L here na 3.2. So, use L 3.2 meters. So, for letter B, minimum size of square spread footing, we have here F is equals to 1.33 times 240. So, F is equals to 319.20 kPa. So, P is equals to 2,000 kilonewton plus 1,200 kilonewton plus 1,463 kilonewton. We're getting 4,663 kilonewton. And the moment is 68 plus 28 plus 200 for B. Ito yun, dito siya. So, given. We're getting pressure is equals to P all over L squared plus or minus 6 M all over L cubed. So, pressure natin na 319.20. Ito siya. Is equals to 4,663 all over L squared plus 6 times 296 na M all over L cube. Trial and error. We're getting L is equals to 4 meters. So, next is minimum size of square protein for letter C. We have here F is equals to 1.33 times 240. F is equals to 319.20. So, we're getting the loads here na 2,780 plus 1,670 plus 1037.8 total of 5,487.50. So, ang M natin here is 70 plus 30 is equals to 100 kilonewton meter. So, pressure is equals to P all over L squared plus or minus 6M all over L cubed. So, yung F natin na 319.20 is equals to yung P natin na nakuha na 5,487.50 all over L squared plus 6 times 100 kilonewton meter all over L cube. We're getting the trial and error here. L is equals to 4.22 meters. For problem number 11, we have here a combined rectangular footing supports and weight. Supports an exterior column na 450 mm square and an interior column of 500 mm square. Placed at a distance center to center equal to 3.6 meter. The exterior column having its face along the property line carries a dead load of 892 kilonewton and a live load of 668 kilonewton. The bottom of the footing is to be 1.8 meter below the grade. Allowable soil bearing capacity is 240 kPa. Weight of soil is 15.74 kilonewton per cubic meter. And that concrete is 23.5 kilonewton per cubic meter. So, ngayon we have here FC prime is equals to 20.7 MPa and FY is equals to 415 MPa. So, to get the A here is equals to 1.3. Reinforcement location factor siya. For top reinforcement more than 300 mm concrete below, we have beta 1 coating factor and gamma 1 reinforcement size factor and lambda na 1 for normal weight concrete is used. So, ito yung figure niya. Compute the dimension of the rectangular combined footing. And next is compute the maximum moment of the footing along the longitudinal section. For letter C, Compute the longitudinal reinforcement needed. And for letter D, compute the transverse reinforcement needed. So the solution is here. For A is dimension of the rectangular combined footing na may effective depth na 650 minus 75. Makakuha tayo ng total niya na effective depth na 575 mm. So effective upward soil pressure to get the QF is equals to 240 minus 23.5. Yung 23.5 dyan is yung unit weight yung weight ng soil, ng concrete, and times 0.65 yung ito, height nung ito, minus 15.74 times 1.15. Yung 15.74 dito is siya yung weight ng soil, and yung height nitong ito yan siya. Makakuha natin yung effective upward soil pressure na 206.62 kPa. So area required is 535 plus 446 plus 892 plus 668 all over 206.62. So makukuha natin here is area na 12.30 square meter. Sabi niya, locate the center of gravity of column loads from the center of the left column. Ito, dito. Ilolocate natin ito. So, itong x na to. So, R is equals to 535. Yung 535 dyan is ito. Plus 446 plus 892 plus 668. Makukuha natin yung R na 2,541 kilonewton. And so, yung x bar natin is equals to 892 plus 0.668 times 3.6 plus 535 plus 446 times 0. So, all over 2,541. Makukuha natin x bar na 2.21. So, length of footing is equals to L over 2. Ayan na siya. Yung x bar natin, ipa-plus natin siya sa 0.225. We're getting the L here na 2 times 2.221 plus 0.225. L is equals to 4.87. LW is equals to 12.30. So, ang W natin ngayon is 2.53. Use 4.87 meter by 2.53. Ultimate upward pressure is equals to QU. Yan. 1.2 dead load plus 1.6 times live load all over area. So, substituting the values, we get the QU as 285.64 kilonewton per cubic meter. For upward force per meter along the length of the footing, we have the QU na 285.64 here times 2.53 na weight na W. Makukuha natin na QU as 701.61 kilonewton per meter. So, next page tayo. Ito yung diagram niya, yung figure na dito. Makikita natin na yung MU is negative 975.37 kilonewton meter. So, shears at sections, we have VA, yan, negative 1,355.6 plus 717.61 times 0.45. Kuha natin yung VA as negative 1032.68, and for VB naman is ilalas na itong 10.32.68 i-minus natin siya doon sa nakuha nating QU kanina na 717.61 times 3.125. So, ang VB natin ngayon is ito 2,939.2 thank you po plus 717.61 times 0.5 ang VB natin ito. So, ang VC natin ngayon is negative 570.5, and then for VD naman is negative 570.5 plus 717.61 multiplied by 0.795, so 0. Locate the position of the point E where the shear is 0. Maximum moment occurs here. So, VE is equals to 717.6 Y minus 1355.6 na yung sa VA natin kanina dito, 0.69 is equals to 0. So, Y is equals to 1.889 meter. Maximum moment, we have MU is equals to 1.889 times negative 1032.68 yung sa VA natin all over 2. So, MU natin here is negative 975.37 kilonewton per meter. Critical section of VU is at point D distance from B. So, VU natin is 1209.85 minus 717.61 multiplied by 0.575. Ang V natin is 797.22. So, to get the phi BU AVN is equals to 0.75. FC natin, FC prime na 20, square root of 20.7 times 2530 times 575 all over 6. So, ayan. Phi VN is equals to 82739 Newton and gagawin natin siyang kilonewton. So, greater siya sa 792.22. Ito, yung V natin, greater siya. So, therefore, it is safe. Punching shear at the interior column. Note natin, ang D natin ay 575 mm. So, ang punching shear natin is 1.2 times dead load, 892 plus 1.6 times LL. Ayan, so ang PU natin is 2139.2 kilonewton. So here we have QU is equal to 79.23 kilonewton. So yun nakuha natin kanina ng PU na 2139.2 is ma-minus na siya sa 283 sa 283.64 times 1.075 squared. So makukuha natin yung VU na 1811.4. Ngayon, to get the BO, 4 times 1075. Makukuha natin siya as 4,300 mm. Again, phi VN is equals to phi square root of FC prime BOV all over 3. So, ito, substituting the values, makukuha natin yung VN natin as, ito, yung phi VN natin na 2812299. Yan. So, convert natin sa kilonewton. So, therefore, mas greater siya sa V natin. Therefore, it's safe. So, continuation, punching shear at the exterior column, PU 1.2 times 535 plus 1.6 and times 446. PU is 1355.60 kilonewton. Now, we have here the VU is 1355.6. Ito siya. Minus 283.64 times 0.7375 times 1.025. We're getting the value of V here na 1,141.1 kilonewton. So, phi VN is equals to phi times square root of FC prime times BD all over 3. Now, we have BO here na 2 times 737.5 plus 1,025. So, B natin is equals to 2,500. Phi VN is equals to 0.75 times the square root of 20.7. Yan yan. Substituting values, we're getting the value of phi VN natin na 1635.06 kilonewton, which is greater than 1,141.1 kilonewton. Therefore, phi BN natin is safe. Now, the dimension of the combined footing is 4.87 meter by 2.53 meter by 0.65 meter. Now, for B, maximum moment of the footing along longitudinal section, MU, we have here 1.889 times negative 1032.68 all over 2, we get the maximum moment na negative 975.37 kilonewton per meter. And for C, we have the reinforcement on the longitudinal section, MU is equals to negative 975.37 na MU natin, kilonewton, is equals to itong MU natin magiging phi F prime C BD square W times 1 less 0.59 W. So, substituting the values here, 975.37 times 10 raised to 6 is equals to yung phi natin na 0.90 times FC prime na 20.7 times base natin na 2,530 times 575 squared na depth times W multiplied by 1 less 0.15 W. So, manipulating it and equating it to 0, we're getting W as 0.0651. W is equals to P Fy all over Fc prime. So, next page tayo. We have here yung continuation niya na. So, W natin is 0.0651 is equals to P times Fy 415 all over Fc prime na 20.7. So, the value of P is equals to 0.0032. P minimum is equals to 1.4 over Fy. So, P minimum natin is 1.4 over 415. Baka natin yung value na 0.00337. And, mas mataas siya sa value ng 0.032. So, ang gagamitan natin ngayon is yung 0.00337 na P. So, here still, we have PBD is equals to 0.00337 multiplied by base na 2,530 and the depth is 575. So, area na steel is 4,903 using a 25 mm diameter bars. We're putting it here. So, pi over 4 times 25 na mm diameter bars is squared and is equals to 4905 na area of steel. Now, and here is 9.9, say 10. Use 10 mm, 10 na 25 mm diameter bars. For, ayan, ganyan siya. Check for development length. Ang development length of top bar natin is C is equal to 75 mm yung cover ng dimension. Now, required development length is LD over DB is equals to 9FY alpha, beta, gamma times lagma all over 10 square root of FC prime times C plus KTR all over DB. So, yung KTR natin dito is 0. Now, we have here, yung sa C plus KTR natin all over DB. So, makuha natin siya as 3. Greater than 3 siya. Ay, ito. 75 plus 0 all over 25 is equals to 3. So, mas mataas yung 3 kaysa sa 2.5. Now, gagamitin natin is C plus KTR na over DB natin is 2.5. So, LD all over DB is equals to 9 times 415 times 1.2 na FY times 1 times 1 times 1. Ano siya? All over 10. Yung FC prime natin na 20.7 and then the 2.5 here. So, we're getting the LD over DB as 42.7. Now, to get the LD, we have yung DB natin kanina na 42.7. So, LD natin is 25 times 42.7. LD is 1067 millimeter. So, therefore, it is required development length. Furnish is LD is equals to 1889 less 75. Therefore, mas mataas tong value na to kaysa sa 1067 na to. So, moment at overhang portion tayo. MU is equals to 717.61 yung nakuha natin value kanina times 0.795 times 0.795 all over 2. Natin to sa dalawa. Ngayon, ang MU natin is 226.77 kilonewton meter. Ito yung formula niya. So, substituting the formula and manipulating it here. Gagawin natin siyang equating it to 0. So, ang W natin is, ayan, 0.0147. Now, we have here, ang formula ng W is equals to P Fy all over Fc prime. So, ang W natin is 0.0147 is equals to P times 415 na Fy all over 20.7 Fc prime. Ang P natin is 0.00073. So, mas maliit siya. Gagamitin natin siya doon. Sa AS natin to get the area of steel, we have 0 P natin ng 0.00073 times 2,530 na base times width na 575. So, ang area of steel natin is 4903 meter square. Using 28 mm diameter bar ng bakal, we have here the pi over 4 times 28 mm squared and let is equals to 4903. So, ang number ng diameter bars natin is 7.9. Sabi natin 8 bars na lang. Use 8 na 28 mm bar diameters. Ngayon for D, transverse reinforcement needed at the interior column. So, we have here the QU 2139.2 all over 2.53. So we're getting QU as 845.53 kilonewton per meter. And then again, MU 845.53 QU times 1.015 times 1.015, hatiin ulit natin to, all over 2. M natin is 435.54 kilonewton meter. Ang M natin, this is the formula. So, substituting na naman natin yung mga values. And then, equating it to 0. Makukuha natin ang W natin as 0.0685. Then here, we're gonna use it again sa W formula natin to get the P. And here's the P. So, 0.0034 greater than P min siya. So, therefore, use 0.0034. For area of steel, we have PBD. So, P natin, again, and base times D. AS is equals to 2102 millimeter square. So, using 22 mm diameter bars, we have here pi over 4 times yung diameter ng bakal. And N is equals to 2102. We have here the N is equals to 5.566 bars. Next page tayo. At the interior column, QU is equals to 1355.6 all over 2.53. So, ang QU natin here is 535.81 kilonewton per meter. So, MU is equals to QU times 1.04. Hatiin ulit natin yan. I-multiply natin dito. So, makukuha natin yung MU na 289.77 kilonewton meter. So, formula na MU, V times FC prime, BD square, W times 1 na 0.59 W. Substituting the values again to get the value of W, equating it to 0. So, 0.0663 ang makukuha natin value ng W. So, we are gonna use it here para makuha yung value ng P. So, here, 0.06639 is equals to P times 415 all over 20.7 na FC prime. So, ang value ng P is 0.033. Ang minimum natin is 0.0337. Therefore, mas gagamitin natin itong 0.00337. Ayan. Kasi mas malaki siya sa 0.033. And now, ang area ng steel natin is PBD. AS is equals to P natin ito times B times D. Value niya is 1429 mm squared. Using 22 again, 22 mm diameter bar ng bakal. We have here pi over 4 times 22 squared and is equals to 1429. So, N is equals to 3.76 say 4 bars. Use 4 na 22 mm diameter. Then 12, we have here a combined footing shown carries exterior column 300 mm by 450 mm at the property line, which is subjected to a total service load. P1 is equals to 890 kilonewton and P2 is 1,557 kilonewton. The level load is 35% of the total load. The bearing capacity of the soil at the level of the footing base is 82 kPa. And the average value of the soil and footing unit weight is 18.89 kilonewton per cubic meter. A surcharge of 4.8 kPa results from slab on the grade FC prime is equals to 20.7 MPa and Fy is 415 MPa. Based on the footing is at 2.13 meter below the grade. Alpha is equals to 1.3 reinforcement location factor. Beta is equals to 1.0 coating factor, and yung Y natin is 0.8 reinforcement size factor, and lambda is equals to 1.0 normal weight concrete used SCP 2010. So ito yung figure niya, ganyan. Now, A, determine the dimension of the rectangular combined footing and check for shear strength. For B naman, determine natin yung longitudinal reinforcement of the combined footing and check for development length requirements. And C, determine the transverse reinforcement of the combined footing at column A and B. So, ito yung solution. Assume total thickness of footing is equals to 875. So, we have here the total effective depth niya na 875 minus 75 mm is equals to 800 mm. So, ayan, ganyan siya. So, effective upward soil pressure So QF is equal to 192 less 18.85 times 2.13 minus 4.8. Ang QF natin is 14705 kPa. Then the area is equal to total depth, yung lalim, total ng lalim niya, all over QF. So makukuha natin siya as 16.64 cubic meter. Ngayon, X bar natin times R is equals to yung load times 0 plus yung load ng 2 times 6. Excuse me. So, X bar natin ngayon is P1 plus P2 is equals to 0 plus 6 P2. Now, we have here the X bar is equal to 6 times 1557 all over 890 plus 1557. Makuha na yung X bar na 3.82. Yung 1557 is ito. Pinag-add lang natin yung loadings. Kaya nakuha natin yung 1557. So, L over 2 is equals to 3.82 times plus 0.15. Excuse me. So, L natin is 7.94 meter. Ngayon, LW is equal to 16.64. So, we have the value of L. Meron tayong L. So, 7.94. W is equals to 16.64. Ang makukuha nating value ng W is 2.10 meters. Use 7.94 by 2.10 meters. Ang ultimate load at column A natin is, yan, ang LL natin is 0.35 times 890. Makukuha natin yung value niya. 311.50 kN. So, DL natin is 890 minus 311.50. Makukuha natin ang dead load na 578.50 kN. So, PAL natin is 1.2 DL plus 1.6 LL. So, values, makukuha natin siya as 1192.60 kN. Then, for the ultimate load at column B, same process. Ganun siya. Makukuha natin ang DL natin as 1012.05 kN. At ang LL is 544.95 kN. So, to get PU2 is equals to, ganyan din, same formula. Substituting the values again from here, makukuha natin siya as 2086.38 kN. Ultimate upward pressure, we have QU is equals to PU1 plus PU2 all over LW. Yung LW natin kanina is 7.94 times 2.1. And yung sa PU1 natin is yung ito, 119.2.60 and plus 2086.38 na ito. Makukuha natin siya as 196.65 kPa. So, next is, excuse me po. Yan. Note, change the circular column into a square section with equal area. So, makukuha natin yung pi over 4 times 375 squared is equal to x squared. Ang x natin is 332 mm. Net upward pressure per meter of longitudinal section. So, Q is equals to 196. Yung nakuha natin yung value dito. So, ultimate, 196.65 times 2.1. Yung 2.1 din is ito. Q is equals to 412.97 kilo Newton per meter. So, VA is equals to negative 119.2.60 plus 412.93 times 0.3. 0.3. VA natin is negative 1061.71 kilonewton. For VB natin, we have ito, 10.68.71 plus 412.97 times 5.86 68 for my is equals to 1278.61 kN. And for VC natin, makukuha natin siya here, negative 670.66 kN. For BD natin is 0. Now, we have here yung VU, 1278.61 minus 412.97 times 0.8. Ang V natin is 948.23 kN. So, to get the VVN, we have here is equals to V squared of FC prime BD all over 6. Value ng V natin is 0.75 times 0 times square root of 20.7 times base na 2,100 and D na 800 and all over 6. So Vn natin is 955,442 Newton. Converting it to kilonewton, mas mataas ang value ng Vn natin kaysa kay Vu, therefore it is safe. So use D as equal to 800 mm. Check for punching shear at column A. Ayan, yung PU1 natin kanina 1196.60. QU natin na 196.65. BO na 2,600 mm. Excuse me po. So, ang VU natin is 1192.60 minus 196. Ito. Times 0.7 times 1.2. We're getting the value of VU na 1027.41 kilonewton. Excuse me. So, yung VVN naman natin, substituting the values again. Pero ang naiba lang dito is yung BO natin na 2,600 and 800 na D. So, all over 3. So, ang PVN natin is mag-equal to 2,365.86 kilonewton. Mas mataas ang value niya kaysa dito sa VU natin na 1027.41. So, therefore, it is safe. Now, moving on. So, ang punching shear at column B natin is PU2. Ayan na siya yung kanina. Ayan, 2086.38. Tapos, ang Q natin is kanina, 196.65. So, ang V natin, less lang natin yung P natin na PU2, less the QU, times 1.132 squared. Makukuha natin siya as 1834.39 kilonewton. And the BU natin is 113, 2 times 4. Is equals to 4528. Now, shear capacity natin. Same process. Makukuha natin yung value ng Vn dito. VVN na 41, 20, 23, 1. So, converting it into kilonewton, 4120.23 is greater than 1834.39 kilonewton. Mas mataas yung Vn natin kaysa sa Vu. Therefore, it is safe again. So, use rectangular footing as 7.94 meter times 2.10 meter by 0.875 meter. Yan, sagot sa A. Then, for longitudinal reinforcement, B, shear at F is equal to 0. So, ang VF natin is 412.97Y is equals to 1192.60 is equals to 0. So, 412.97Y is equals to 1190.60. Ipat natin doon. And next is Y, ang makukuha natin Y natin is 2.99 meters. So, maximum moment is equals to 2.89 times 1068.71 all over 2. Max M is equals to 1544.39 kilonewton meter. MU, yan, is equals to phi F prime Z BD squared W 1 minus 0.59. Ganyan siya. Substituting the values, manipulating it and equating it to 0. Makukuha natin ang value ng W na 0.064. So, to get the P, i-substitute natin to dito sa W natin. And then, yung Fy natin na 415 all over 20.7. Makukuha natin yung value ng P na 0.00319. So, mas mataas yung value pa rin ng P minimum natin na 0.0037 kaysa kay P natin na nakuha na 0.00319. Therefore, use P as 0.00337. So, area of steel is equals to PBD. Now we have the P base and the depth. So we're getting the value of AS as 5662 millimeters squared. Now moving on to our next page. We have here using 20 mm bars. We have pi over 4 times 20 na diameter bars squared and is equals to 5662. Now, ang number of bars natin is 18 bars. Use 18 na 20 mm diameter bars at top sa taas. So, development length, LD over DB is equals to 9. Ayan. Fy alpha beta lagma. All over 10 F prime C square root times C plus KTR all over DB. So, ang C natin dito is 75 mm, still covering yun. And ang KTR at DB natin is 0. So, therefore, ang C plus KTR over DB natin ay is equals to 75 plus 0 all over 20 is equals to 3.75 greater than 2.5 siya. So, use natin itong 2.5. LD all over DB is equals to 9 times Fy 415 alpha 1.3. Yung beta natin is 1.0. Then, gamma na 0.8 and lambda na 1.0 all over 10. Ang F prime natin C is equals to square root of 20.7 times 2.5. Therefore, ang LD over DB natin is equals to 34.15. Now, LD is equals to 20 times 34.5, 15 is equals to 683 millimeter required. LD furnished is 2890 less 75 less 2815 millimeter is greater than 683. Now, reinforcement at the overhang portion, we have MU 415.97 times 1.624. Ayan, hatiin na naman sa dalawa, i-multiply natin dito sa formula. We're getting MU as 544.58 kilonewton meter. And then here, again, the formula for MU. Substituting again the values na nakukuha natin dito. Then equating it to 0, makukuha natin yung value ng W, 0.022. And to get the P, ito, yung formula ng W, substitute again, makukuha natin yung value ng P na 0.0011, use P mean na 0.00337 kasi mas malaki ito, mas safe siya. AS is equals to PBD again, PBD, area ng steel natin is 5662 mm squared. So, using 20 mm diameter bars naman tayo, pi over 4 times 20 raised to 2 I squared, N is equals to 5662. Ang N natin is 18 bars. So, therefore, use 18 na 24 mm diameter bars. Yun yung sagot sa B. And C, transverse reinforcement at interior columns. So, Q is 2086.38 all over 2.10. Ang Q natin is 993.51 kN per meter. Ang M natin na is, ito yung Q, times 0.884 times 0.84 over 2. Ang makuha natin MU is 388.2 kN meter. Now, to solve for W, gamitin na natin itong MU natin. 0.90 times 20 FC prime, 0.7 times B na 1132 times 800 squared na D times W times 1 less 0.59W. Ayan, equating it to 0. Makukuha natin yung value ng W na 0.0293. So, therefore, W is equals to P 415 na Fy all over 20.7 na FC prime. So, ang P natin is 0.00146. Use P minimum natin na 0.00337 kasi mas malakas yung value nito. Now, we have yung area ng steel again na PBD. So, P base depth is equals to 3052 mm squared. Using 20 mm diameter bars ng bakal, we have here pi over 4, 20 mm, ito, raised to 2, and is equals to 3052. Ang number natin is 9.7, say 10 bars. At exterior column A, we have Q 1192.60 all over 2.10 minus 567.90 kN per meter. MU is equals to 567.90 times 0.85825 times 0.825. Hati natin lang sa dalawa. Ito, multiply. Then, MU is 193.27 kN meter. So, ang MU natin, again, gagawin na naman yung ginawa natin dito. So, substituting the values again. Ayan siya. Makukuha natin yung value ng W here. So, equating it to 0. W natin dito is 0.029. So, sa W, we have a formula na P, Fy over Fc prime. So, to get the P here, 0.023 is equals to P times 415 na Fy all over 20.7 na Fc prime. Ang P natin is 0.001. Use P min na 0.0037 kasi mas safe siya. So, area na steel, we have PBD again. PBD, so area steel is 1887 mm squared. Using 20 mm bars, we have pi over 4 times 20 raised to 2 and it's equals to 1887. Makukuha natin itong number ng bars na 6 bars. Ayan, so last problem tayo. Number 13 for plate number 2. A rectangular combined footing carries the given tabulated load. So, ito siya. Given natin. So we have here, the total depth of the footing is 460 mm with an effective depth of 376 mm. The bottom of the footing is 1.8 meter below the final grade. allowable. Soil pressure is 906, wrong. Is 96 kPa. Unit weight of soil is 15.7 kilonewton per cubic meter, and that of concrete is 2,400 kilogram per cubic meter. So, ang FC pre natin is 20.7 MPa, and ang FY natin is 414.7 MPa. The face of the exterior column is located on the property line. Distance between two columns, center to center, is 4.6 meter. Use 2001 NSCP specs. So, which of the following gives the dimension of the rectangular combined footing? B. Which of the following gives the shear stress or punch at the critical section near the exterior column? And C. Which of the following gives the number of 28 mm diameter reinforcement needed along the longitudinal section of the combined footing? So, the solution, we have here dimension of combined footing. We have effective soil pressure. QF is equals to 96 less 1.34 times 15.7. Yung 15.7 din is ito. Yung weight ng soil. Minus 0.46 times 2,400 times 9.81 ng gamma ng water all over 1,000. Kasi, for conversion natin. So, QF is equals to 64.13 kPa. Area required is LW is equals to 536 plus 890 all over 64.13. Inakuha natin QE natin. And this one is the area. So, LW is equals to 22.24 meters squared. Locate the center of the footing. 1,426 x is equals to 890 times 4.6 plus 536 times 0 plus 54 plus 81. Ang x natin is 2.96. L over 2 is equals to x plus 0.15. We have here yung value niya. Ang makuha natin L is 6.22. Now, to get the W naman is 6.22. Ayan, sa LW natin. 6.22 W is equals to 22.24. Ang W natin is 3.58 meters. So, ito yung figure niya, ganyan. Now, for B, punching stress at exterior column, we have PU1 is equals to 1.4. Dead load na 268 plus 1.7 and LL na 268 is equals to 830.8 kilonewton. Then PU2 is equals to 1.4 times 490 na DL lang naman for plus 1.7 times 400 LL is equals to 1366 kilonewton. Next, we have here next page niya. Net upward soil pressure is equals to 830.8 plus 1,366 all over 6.22 times 3.58. So, ito siya. Ganyan. Ayan. So, ang Q ultimate natin is, QU natin is 98.65 kPa. So, VP is equals to 830.8 less 98.65 na QU times 0.676 yung ito times 0.488. Ang VP natin is 798.26 kilonewton. So, UP is equals to VP all over phi BD. So, BO is equals to 488 times 2. Ito yung 488 natin. Ang length na yan. Multiply natin sa dalawa. Plus 676 is equals to 1652. UP is equals to 79. Gawin natin Newton to. 798,260 all over 0.85 times 1652 BO times 376. Excuse me. So, ang UP natin is equals to 1.51 MPa. Then, for C, we have here number of 28 mm diameter reinforcement along the longitudinal section. So, hahanapin natin yan. Upward pressure along the length. We have QU is equals to 830.8 plus 1366 all over 6.22. Now, we have QU is equals to 353.18 kilonewton per meter. Ang VA natin, ayan, yung QU natin times 0.30. 0.30 yan is ito. Nasaan tayo? Minus 830.8. Ang makukuha natin value ng VA natin is negative 724.845. For BB natin is VA plus 353.18 na QU times 4.2625. Ang value ng VB natin is positive 780.584. So VC natin is ito, VB plus 358.18 times 0.375 less 1,366. Yun. Makukuha natin VC natin is negative 452.974. Then for BD is magiging 0. Ayan siya. Shear and moment diagram. Excuse me, marginal. And shear is 0 at maximum moment. So yes, 353.18y less 830.8 yan siya. Is equals to 0. So ang y natin is 2.35. Ang maximum moment natin is 734.846 times at y all over 2. So ang maximum moment is negative 851.69 kilonewton meter. And U is equals to 851. Yung Nmax natin, yun na siya. So, itong formula na to, ng MU is phi, FC prime, BD square, W, times 1 less 0.59 W, we're getting the value ng, to get the value ng W. So, substituting the values again, MU na 851.69 times 10 raised to 6 times phi natin na 0.90 multiplied ng FC prime na 20.7 and base natin na 3580 times D na 376 squared W times 1 less 0.59 W. So, transpose, equating the equation to 0, have W natin is 0.095. So, P is equals to W, FC prime is equals to Fy, over Fy pala, makukuha natin yung P natin. So, ito siya, 0.095W times 20.7 na. Ayan, FC prime all over Fy, Fi 414.7 Fy. Ang P natin is 0.047. So, P min natin is 1.4 over 414.7. Mas mataas yung value ng 0.0047 dito. So, nakuha natin. Ang gagamitin natin ito para mas safe. So, ang area ng steel natin is PBD. is equals to area ng steel is equals to P na 0.0047 times B natin ulit na 3590 times D na 376. Ang area ng steel natin is 6327 mm squared. So, pi over 4, we have 28 squared N is equals to 6327. So, number ng hinahanap natin na ayun, yung reinforcement along longitudinal section is 10.27. Say 12. Kaya bakit 12? Ni-round up natin ng 12. Kasi sabi niya, note spacing of bar should not be greater than 300 mm. Therefore, use 12 na 28 mm diameter bars.